Hello students. Hello and welcome to this video. In this video, we will solve question number 111 to 120 of determinants. At the link to download the PDFs will be in description. At the end, I will show you how you can download latest PDFs and maintain an updated copy. Also, I will show you my question answer website where you can come and ask questions related to mathematics or programming, because YouTube comment box is not really suitable for typing mathematical symbols. So first, what we do is we get 107 out of way and 110. So 107 was incorrectly typed out. Okay. So this is the revised problem which we have. We have xf prime here instead of f prime, xg prime, and xf prime. So now you have the corrected solution as well. It was 4, instead it is 2 now. So now we have the proper solution of 107. 110 also, we had a typing mistake here. Instead of plus, this would be multiplication. Okay. So these two corrections are mandatory. I have not yet updated this on the website. I will update it very soon. So without further ado, let's get started with question 111. So question 111 says that prove that the determinant 1 cos beta minus alpha, cos gamma minus alpha, cos alpha minus beta, 1 cos gamma minus beta, backslash is missing, cos alpha minus gamma, cos beta minus gamma, 1 is equal to 0. So if you look at this determinant, it would be product of sin alpha cos alpha 0, sin beta cos beta 0, sin gamma cos gamma 0, and sin alpha cos alpha 0, sin beta cos beta 0, sin gamma cos gamma 0. Both the determinants have 0 as a column, that is a column entirely made up of 0, so the product will be 0. Question 112 says that for what value of m does the system of equation 3x plus my is equal to m and 2x minus 5y is equal to 20 has a solution satisfying the conditions x greater than 0 and y greater than 0. So first we compute delta. Delta is minus 15 plus 2m. So delta will be 0 when m is equal to minus 15 by 2. Now delta 1 is equal to minus 25m, which will not be equal to 0. So the given system of solution will have, given system of equations will have no solution when m is minus 15 by 2. Now we take the second case when m is not equal to minus 15 by 2. Delta 2 would be 2 times 30 minus m. So our x is 25m upon 15 plus 2m. Now there would be two cases, that is m lies between minus infinity and minus 15 by 2, and the second is it will lie between 0 and infinity. So now y will be delta 2 upon delta, which will be greater than 0. So y is greater than 0. Okay, so this is for x greater than 0. Now from this we have minus infinity, that is m lies between minus infinity and minus 15 by 2, and m lies between 30 and infinity. So combining both, we get that m should lie between minus infinity and minus 15 by 2 and 30 and infinity. Question 113 says that prove that the system of equation 3x minus y plus 4z is equal to 0, x plus 2y minus 3z is equal to minus 2, 6x plus 5y plus lambda z is equal to minus 3 has at least one solution for any real lambda. Find the set of solutions when lambda is equal to minus 5. So we have delta is equal to 7 times lambda plus 5. So when lambda is not equal to 5, delta is not equal to 0, which means the system of equations will have unique solution. Now case 2 is when lambda is equal to minus 5, that is delta is equal to 0. So we compute delta 1, delta 2 and delta 3, all three become 0. So we will have infinite solutions for given system of equations. Now putting in the value of lambda, the set of equation becomes only third equation will change, right? 6x plus 5y minus 5z. So solving this, you will find that if x is equal to t, y is equal to 1 minus 13t upon 5, and z will be 4 minus 70 over 5. Question 114 says that for what value of p and q the system of equations 2x plus py plus 6z is equal to 8, x plus 2y plus qz is equal to 5, And the third equation is x plus y plus 3z is equal to 4 has no solution, unique solution or infinite solution. So we see this. We have delta is equal to p minus q times q minus 3 upon evaluation. Delta 1 would be p minus 2 times 4q minus 15. Delta 2 is 0 and delta 3 is p minus 2. Now first case is when delta is not equal to 0, that is p is not equal to 2 and q is not equal to 3. Now given system of equation will have unique solutions here. Case 2 is when delta is equal to 0, p is equal to 2 and or q is equal to 3. P is equal to 2 implies delta 1 is equal to 0, delta 2 is equal to 0, delta 3 is equal to 0. So given system of equations has infinite solution. When q is equal to 3, delta 1 is not equal to 0 and thus given system of equations has no solution. Question 115 says that let lambda and alpha be real. Find the set of all values of lambda for which the system of equations lambda x plus y sin alpha minus z cos alpha is equal to 0. X plus y cos alpha plus z sin alpha is equal to 0. Minus x plus y sin alpha minus z cos alpha is equal to 0. So for non-trivial solution, delta should be equal to 0, that is this determinant should be equal to 0 or lambda is equal to sin 2 alpha plus cos 2 alpha. If lambda is equal to 1, sin alpha plus cos 2, sin 2 alpha plus cos 2 alpha is equal to 1. So we put sin 2 alpha is equal to, there is, okay, from here we get sin 2 alpha is equal to 1 minus cos 2 alpha. So this 1 minus cos 2 alpha from trigonometry becomes 2 cos square alpha. Now we take 2 sin alpha common, cos alpha minus sin alpha is equal to 0. So sin alpha is equal to 0 or tan alpha is equal to 1. So alpha is equal to n pi or alpha is equal to n pi plus pi by 4 where n is in the set of integers. Question 116 asks us to evaluate the determinant a b plus c a square, b c plus a b square, c a plus b c square. So here we do column 1 is equal to column 1 plus column 2. We get a plus b plus c in the first column which we take out and we have 1 left. So once we have ones in 3 columns or rows, we know the ritual, that is R3 is equal to R3 minus R1 and R2 is equal to R2 minus R1. We get this. And then we evaluate against this one. We get the final evaluated equation as or expression as minus a plus b plus c times a minus b times b minus c times c minus a. Question 117 asks us to evaluate the determinant square root of 13 plus square root of 3, 2 square root of 5, square root of 5, square root of 15 plus square root of 26, 5, square root of 10, 3 plus square root of 65, square root of 15 and 5. So here what we do is R2 is equal to R2 minus square root of 2 R1 and R3 is equal to R3 minus square root of 5 R1. So we get 2 zeros in the third column and then we evaluate along the first element of the third column and we get 15 square root of 2 minus 25 square root of 3. Question 118 asks us to evaluate the determinant x times x squared plus 1, x plus 1, y times y squared plus 1, y plus 1, z times z squared plus 1 and z plus 1. So here what we do is that we split the third column, okay? So if we split the third column, this becomes xyz and this becomes 1, 1, 1. Now if you look at the first determinant, xyz and xyz in the first and third column are equal, so it becomes 0. Now we are left with this. Now what we do here, we split the second column. So we get x cube, y cube, z cube here, and we will get xyz here. Okay. Okay, there is something wrong in the typing. So essentially this should be 1, 1, 1. Okay. This shouldn't be x cube, y cube, and z cube. This should be xyz and this should be 1, 1, 1. Let me think. Okay. So this should be xyz and this should be 1, 1, 1. Okay. So this determinant becomes 0. There is huge typing mistake again here. So we take this determinant and we evaluate it. We get x minus y times y minus z times z minus x times x plus y plus z. Again, you need to do R2 is equal to R2 minus R1 and R3 is equal to R3 minus R1 for this determinant. and we'll have the solution. Question 119 says that if x, y, z are respectively lth, 2nth, and 3nth term of an HP, then find the value of yz, zx, xy, L, 2n, 3n, 111. So we let A and D be the first term and common difference of the corresponding AP, then 1 upon x will be A plus L minus 1 into D, 1 upon y will be A plus 2n minus 1 into D, and 1 upon z will be A plus 3n minus 1 into D. So what we do is we multiply first column by xyz and we also divide by xyz. So in the first row, the first row becomes 1 upon x, 1 upon y, 1 upon z. Now we put these values A plus L minus 1 into D, A plus 2n minus 1 into D, A plus 3n minus 1 into D. So you see what happens is you can split this determinant into two determinants. You keep A in one and L minus 1 into D, 2n minus 1 into D, and 3n minus 1 into D. So you will have A in the first row. Once you have that, you can take A common and it will become 1 on 1, which will be equal to third row. So it will be 0. The other determinant which you will find by splitting will have L minus 1 into D, 2n minus 1 into D, and 3n minus 1 into D, which is written here. Once we have that, or we can, instead of splitting, you can simply perform R1 is equal to R1 minus AR3. So we have left with this. Once we have this, what we do is R1 is equal to R1 minus R2 minus 1 into D. So once we do that, our top row becomes 0. And we know that when the entire row is 0, the determinant will be 0. Question 120 says that show that 1a square a cube, 1b square b cube, 1c square c cube is equal to ab plus bc plus ca, 1a square, 1b b square, 1c c square. So here what we do, we take the first determinant and we do R2 is equal to R2 minus R1, R3 is equal to R3 minus R1. So we get 2 zeros and we have 1. Now all we have to do is do the manipulation and it will be equal to b minus a times c minus a times c minus b times ab plus bc plus ca. And the second determinant 1a square, 1b b square, 1c c square we have already evaluated to be b minus a times c minus a times c minus b. And thus we have left hand side is equal to right hand side. Okay. So this is how we solve determinants and we have completed till question 120. Now I will show you my website, that is astrocker.org. We come here, the second, third, and fourth links are the PDFs of algebra, trigonometry, and coordinate geometry. When you download the PDF, you won't have this date. So you see that when you download, you need to add the date to your PDF. And after 15 or 30 days, you can come again and download the PDF and add the updated date. For example, trigonometry was coordinate geometry was updated on 16th, and algebra will be updated in a day or two. Okay. So when you download, you update the date. I cannot put the date in the PDF. The reason is if I do that, then all the existing links in YouTube will become invalid when I update the date in the PDF. Okay. Now, for asking and answering questions, you come to hsync.astavakkar.org, and here you can make a login and ask questions related to algebra, calculus, coordinate geometry, probability, trigonometry. And if your question does not fit all these, then you use the tag mathematics. Okay. I'll be more than happy to answer your questions, or if I don't know, maybe somebody else will answer your question. So the idea is to build a community and learn and do it together. So with this, I will end this video here, and I hope that you have enjoyed this video and found it useful. So we will meet again tomorrow with 10 more problems on determinants. Till then, I will say bye to you, and you stay curious, keep learning, and most importantly, enjoy.